this video, I'm going to show you guys another word problem on quadratic functions. Okay, so please go ahead and pause the video and read what the question is about. Okay, welcome back. I hope you guys have read the question. So here, this is a very typical physics question, and also a very popular quadratics word problem when it comes to quadratics, right, basically. Now, the equation here, h is equal to 24t minus 4.9 t squared plus 1. That gives me the height of a ball. So we have a ball flying in the air, and the height of the ball is this equation right there, where t is just time, right? T is the time, t seconds. For part A, they want us to find the maximum height. So what I'm going to do is first, so here I'm writing this with the mouse, so my handwriting is going to be a bit ugly. So please bear with me. Okay, so 4.9. I'm going to rewrite the equation in standard form. So I will have negative 4.9 t squared, negative 4.9 t squared plus 24t, and then plus 1. And the reason why I do this is to have a better picture of my parabola. My leading coefficient, my a, is negative, right? My a is negative. This is negative, right? My a is negative, which means my parabola opens down, right? And if my parabola opens down, my vertex is gonna be a maximum point, which is what part A is asking us. Right? They want us to find the maximum height. In other words, we are interested in the vertex. Okay, so to find vertex, vertex is just a point. To find vertex, I hope you guys know how to do this now. So it's just negative b over 2a, and that will give me my x coordinate. To find my y coordinate, I'm just going to simply substitute whatever my x coordinate is into my original equation. Right? So let's do that. So if you put the values in your calculator, your v is equal to negative b, where b is 24, so that's negative 24, over 2 times my a is negative 4.9, negative 4.9. Okay, and that's my x coordinate. And we'll work on the y coordinate later on. So if I put that in my calculator, I'm going to pull out my TI-84 in a second. So if I put that in my graphing calculator, I will have, turn it on. So I'm going to go to alpha and then y equals 2. That will give me a fraction. So it'll be 1. Let me do that again. Alpha, y equals. That gives me a fraction. And then I'm going to have negative 24. Please don't use the subtract over here. Negative is right there, okay? Negative 24 over 2 times negative 4.9. And then equal to, so my x coordinate is 2.45 to 3 significant figures, 2.45. Now, if I want to find what's my y coordinate, all I have to do is to substitute my 2.45 into my original equation. Right? So I'm going to put that in my original equation. In this case, it would be the height over here. So I'm going to put that in my calculator. So I have 24, or I could use the better standard equation I have there. So I'll use negative 4.9 multiplied by 2.45 squared, and then plus 24 times So as you can see, I could use the multiply, or I could use the parentheses to represent numbers multiplying each other. Okay, so you can do that too. And then finally, plus 1. So negative 4.9 multiply my t is equal to 2.45 squared plus 24 times 2.45 plus 1. And I have 30.4. Right, 30.4. 30.4. So let's try to put these numbers in context. What does my x coordinate represent? Here I only have h and t. Right? There's no x, there's no y. So we ourselves need to know what does my y represent, what does my x represent. In this case, my x represents the time, right? And my y represents the height. Which means this is my maximum height. This is the maximum height. Max height. Okay? And when does my maximum height happen? When time is equal to 2.45. Right? When time is equal to 2.45, that's when the object reaches the maximum height, which is 30.4 meters. Right? So this is your part A. Now for part B, they're asking us, for what length of time will the ball be higher than 20 meters? Right? Will the ball be higher than 20 meters? So right now they are saying that. So in this case, I'm going to use the graphing calculator to help me out. Okay. So let me just pull out my calculator. So I know that my parabola is going to look something like that, right? Something like this. And for part B, they're asking for, so this is when height is equal to 20. The parabola represents the height of my object, and this red line represents the height of 20. So they're asking how long, right? How long is the object at a height of greater than 20? Right? So that will give you some certain time, maybe time 1, and maybe this will give you another time, maybe time 2. So they're asking us how long was the object higher than 20 during that time. Okay? So I'm going to use a calculator to help me out. Alright, so let's do this. Let's turn it on, and I'm going to go to my equation, and I'm going to put my height equation in there. So negative 4.9 x squared plus 24 x plus 1. Right. And that will give me my graph of the height of the object. Now, I don't really see the entire graph, and in fact, I'm missing my vertex right there, right? So it would be nice, and in fact, we should see the vertex. We should see the entire parabola. Vertex is very important, so we should see the vertex. And since I know that my vertex is at 30.4, right, my 30.4, so I'm not going to use zoom out now. I could, but in fact, I'm going to adjust my window. So go to your window button. So the window function will allow us to sort of look at or focus on the part that we want to see. Right now, your window starts from -10, which is a waste of space. So we have all this space here that's not being used. So I'm going to start from maybe -1 to give myself a little bit more space on the right. Max is 10, that's fine. My y, -10. So that's a bit too much, I would say. So maybe -5, that's enough. But my y max, since my maximum point is at 30.4, so for my y max, maybe I'll give myself maybe 35. And then go back to my graph. There you go. So we see a better better zoom, right? A better zoom of the graph. Now, my vertex is right there, and if you check, so go to second calc, and you go to maximum, they'll want you to choose left bound, so make sure you go somewhere on the left of the vertex. So somewhere there, that's good enough. And then right bound, somewhere on the right, the vertex. The guess value somewhere close to it. So it's 2.45, right? Exactly what we have there. And the height is at 30.4, so 30.4. That's awesome. Okay, now for the part that we're working on, part B, 20 meters. So we need to find when does the object have a height of higher than 20 meters. So what I'm going to do is I'm going to put this, I'm going to move this here. I'm going to go my y equal to, and I'll put another 20 there. With my graph. So there you go. So I have something that looks exactly as a sketch that I have here. Right? And what do we have to do now is look at this. So this point, whatever the x value is, that will be my t1. And this intersection there, that will be my t2. I'm going to go to second calc, and I'm going to go to intersect. So they want us to choose the first curve. So my first curve is the height of the object, so that's good. So it's the blue line, click on that. And the second curve is my red line, that's good. And they want us to find a guess value, so maybe they intersect somewhere there. So close enough. So they will intersect at 0.9929 blah 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 blah, right? So which means my T1 is approximately 0.992. T1 is approximately 0.992. Right? And my T2, I do the same thing. So second calc, I go to intersect again. And then I'm talking about the first curve, which is the height, that's good. The second curve is the red line, that's good. And now the guess value is somewhere there, that's good. Enter. Intersection is at 3.90. This is 3.90, so 3 significant degrees. So it will be 3.90. Right, so between those two times, my object is higher than 20 meters. So they want us to find the length of time. So from T1 to T2, the length of time would be 3.90 minus 0.992. And that will give you, so now I go back to my calculator, 3.90 minus, please don't use this is negative, minus 0.992 equal to 2.9, so approximately 2.91 seconds. Okay, so remember that we should always work on our math notations. So that means approximately, or you can do this if you want to. They mean the same thing. So over here, I should have used, over here I should also use approximately sign. Okay, just fix this real quick. This is also approximately, and that is also approximately. Alright, I hope you guys find this video helpful, and I'll see you guys in the next video.